chances are, if you fly a lot, you've experienced a bumpy ride or two.
Turbulence as a result of stormy weather is easy for pilots to detect and to fly around. But tonight, meteorologist KaitlynMcGrath explains the turbulence we can't see is being impacted by climate change.
You could be flying through a beautiful blue cloudless sky when out of nowhere, turbulence hits. It's known as clear air turbulence, and for good reason. There are no visible signs, and it's undetectable on radar and satellite imagery. New research shows that rocky rides may become more common, and like the turbulence, the link to climate change is clear. To learn more about the first of its kind research, we hop across the pond to the United Kingdom. Paul Williams is a professor of atmospheric science at the University of Reading who has dedicated more than a decade to researching the answer to a question posed by a colleague. What is climate change doing to turbulence?
I had to confess I had no idea. I had to look through the scientific literature and there was really nothing out there. So it was a complete unknown.
Paul immediately dove into dissecting the connection between climate change and air turbulence and has since found clear evidence for strengthening turbulence across the globe in the jet stream region. It all has to do with a law of atmospheric dynamics called thermal wind balance.
And it tells us that north-south temperature differences are what drive wind shear in the jet stream, vertical wind shear.
Climate change as a result of greenhouse gas emissions is causing temperatures to rise more rapidly in the tropical parts of the planet than the polar regions. This temperature contrast is leading to strengthening wind shear, the change in wind speed and direction with height, which creates turbulence. Paul and his team of researchers found that the amount of wind shear in the jet stream has increased by 15% since satellites began observing it in the 1970s. He does project that turbulence may become 2 to 3 times worse in the upcoming years.
That is not based on a climate model projection of the future. This is something that's already happened in the atmosphere.
Jim Kinter, a professor of climate dynamics at George Mason University, is also forecasting for the future. He specializes in long-term modeling of the atmosphere in our changing climate.
So if we're seeing an increase in clear air turbulence as a result of these changes in the large-scale circulation of the atmosphere, then there's the potential for more danger in the future.
Oftentimes, pilots only become aware of clear air turbulence after a fellow pilot has experienced it and radioed in the report.
We'll need better systems for detecting clear air turbulence. There are ways to do it. They're expensive and they're only in limited places, so it may be quite a challenge.
Researchers are hopeful the newest generation of computer modeling, available in the next 5 years, will be much better at predicting these unpredictable forecast challenges.
If we had forecasts that could be issued in real time to pilots as they're in the air, then the pilots could get that information and they could take evasive maneuvers or find ways to avoid the bad areas.
Boy, this is really eye-opening, and I guess the question is it still safe to fly with turbulence? I know when I feel it, I sort of like grab onto the sides.
Yeah, you feel a little pit in your stomach.
Don't move.
But the answer is yes, commercial airplanes are built to withstand severe turbulence. But the big takeaway from the FAA is even when the seatbelt light is on, stay buckled up. It is the best way you can protect yourself.
Mm-hmm. Where were you going when we saw you on that flight at the beginning of the story?
That was
somewhere nice and tropical.
Sand in her toes.
Yeah.
Yes, she always travels in a beautiful dress and heels.
And you had leg room too.